Welcome for the demonstration of zero voltage switching for SCR and TRIAC. So you can see the layout of the panel. This is the output of step down and isolating transformer over here, which is to be connected to the main circuit. Then these are the just block diagram of the ZVS firing circuit, where we are giving two inputs. One is a number of cycle control, which is a reference, which is the output of this potentiometer, which is a DC. Then cycle time reference. So total cycle time is this pot where the output of this DC is connected over here. Then this is the main AC is getting into the ZVS firing circuit, which is as a reference 50 Hertz. Incoming reference is given to the ZVS firing circuit. So then the output of this is given to the opto isolator, which has to be connected to the particular device. So the output of this ZVS firing is available here with respect to the ground. So the MT1, MT2 terminals or the cathode terminals is nothing but a ground also of a firing circuit, which is to be connected to the MT2 terminal get as per the color code of the wire, and MT1 to MT1. So we have two devices here. One is a TRIAC, another is a SCR. Then as a load, we have provided two types of loads. One is 250 ohms resistive load. Second is a 100 ohms resistive load. That is a load 2. This across load, this LED lamp is connected, which is across this terminal it is connected. So whenever you connect a load, some load, either this load or second load, always the LED is getting connected across that. So you have to observe the final output across this LED only, which is across the resistive load also. Now secondly, we have SCR. So instead of a TRIAC, you can use a SCR also. So for using a SCR for the same circuit, we have to configure it as a anti-parallel thyristor, right? Then only it will work in the both cycles of AC circuit or AC cycle, positive half cycle and negative half cycle. Now this is all about the patching and where to observe the firing waveforms, where to observe the final output. But first thing, you have to understand that what is the meaning of ZVS. We have used here as a reference 50 Hertz incoming supply, where according to that we are getting a zero voltage switching zero crossing detector first. So this is zero crossing reference, where we are getting a square wave output from the firing circuit, which is an acknowledgement of it is able to understand or detect the zero crossing of every cycle, right? So for every 10 milliseconds it is able to acknowledge that zero crossing, or every positive half cycle out of the full cycle. That out of 50 Hertz, the positive half cycle will be every 20 milliseconds. So that has been acknowledged by the square wave, and then the final firing pulses have been generated according to this zero crossing detector. So now there are 2 points or 2 potentiometers. One is the number of cycles and second is the cycle time control. So zero crossing detector is you just observe the waveform here, the output waveform, right? The output waveform, just we are connecting a CRO here. So correct. So we have connected a CRO. So right now, whatever may be, I'll just change the control mode first. Yes. So I'm keeping the duty cycle number of cycles increasing and at 100%. So you can see now we are getting a complete AC output. So there is no control of the number of cycles. It is a continuously AC. So in any of the case, when we want to control the amount of power given, we are not going to control here firing angle. We are just going to control either exactly at a 0 for that complete AC cycle. Yes, so for complete AC cycle, the output will be on, and so you can see here for 3 cycles the output is on, right? And after that the output is off for the remaining part of the total cycle time. So I don't know how many remaining part of the cycle time right now. So that's what I'm saying. This is the duty cycle or number of cycle control. So out of the available right now, I'm controlling switching on only 3 cycles. So this is the difference between a firing angle control and ZVS. We are exactly switching on at a 0, either in a positive half cycle or a negative half cycle, and then we are controlling up to the end of the that complete cycle up to 0, right? Exactly. So this is 1, this is 2nd, and this is 3rd. So 3 cycles we have controlled, and then we are stopping it, right? And we are stopping it at 0 only, we are not stopping it anywhere in between. So that's why it is a kind of a soft start unit or soft control unit, right? We are not controlling or switching on any load in between of the main AC cycle. So this is the how typical ZVS waveform should look, and this is how it has been looking. So this is the main thing. Then now I am going to increase the number of cycles like this. I am increasing the number of cycles right now. So I have increased it, and again it has become complete, this one. So I slightly have decreased it now, right? So once I have slightly decreased it, I have found out that there are 4 cycles, and after that there is one gap. So it means whatever the total cycle time I have right now selected allows me to have a total 5 cycles. After 5 cycles, I will say one complete control set has been completed, right? And it is going to the next cycle time. So that total right now, if I say total 5 cycles is 100%,